We're going to go through a problem that involves a velocity time graph, specifically when we have to deal with area under the curve. This is coming from classwork number 3, problem number 5. The situation we're given here is a girl kicks a soccer ball up a hill, and as it goes up the hill, it's going to slow down, and she's walking up the hill to meet it. So the ball goes up, reaches its highest point, rolls back down, and she meets it somewhere part way at the end time of 5 seconds. So we are asked at what time the ball changes direction and begins rolling back down the hill. And looking at the graph, the change of direction would be represented right here when the velocity is going from positive to negative. So the time that that occurs will simply be 3 seconds. Next, we want to know the acceleration of the ball as it rolls up the hill, and again as it rolls down the hill. To find acceleration from a velocity time graph, we're going to use the slope, which is the rate of change of velocity as a function of time. That is, by definition, acceleration. And looking at this graph, it's pretty obvious that the acceleration, the slope, is staying constant throughout the whole motion. So whatever the acceleration is rolling up the hill, right here, it's going to be the same as it's rolling back down the hill. So all we need to do then is find the slope, which is delta y over delta x, and on the y-axis we have velocity. And just to keep things simple, I'll only look at the positive value here. So I've got, that's from 0 to 3 seconds. 0 would be the final velocity minus 12 meters per second divided by a total of 3 seconds gives us a slope of 4, and the correct units would be meters per second squared. Sorry, that's negative 4. And that same slope continues throughout the rest of the problem. Next, we want to know how far up the hill the ball travels before it begins to roll back down. So we want to think about this and think, what does this actually mean? This represents the portion when the ball has a positive velocity. That is from here to here. Basically, what we're looking for is the displacement of the ball for the positive section of this graph. And that will be the area under the curve of this section. So we have a triangle. The area is going to be equal to 1/2 the base times the height, and that is 1/2 times 3 times 12. And that is equal to 18 meters. So it's rolling up 18 meters. Now we want to know the total distance traveled by the ball during the 5 seconds. So in order to do that, we're going to have to figure out how far it rolls back down. That would be the negative portion of the displacement here. So again, I'm going to find the area 1/2 base times height of the negative section. So that's, I'm about to run off the paper, 1/2 times the base is 2 times a height of, what do we have here, 8. So this area here is 8 meters. Now, strictly speaking, we can't have a negative area geometrically, but this represents negative displacement. So I'll make sure I don't forget that and call that negative 8. So the ball travels 18 meters up the hill and then 8 meters back down for a total of, let's see, 18 meters up plus 8 meters down. And in this case, we're talking about displacement, so direction does not matter. We're looking for the total distance traveled. That's why we're adding, and we get a total of 26 meters. Finally, we want to know how far up the hill did Susie walk between the time when she kicked the ball and the time she met up with the ball at 5 seconds. In other words, we're really just looking for the total displacement of the ball, which is going to be used the same information, but we're not dealing with distance. We're looking at only the beginning and end position, which means the directions here are going to matter. We have 18 meters of positive displacement, negative 8 meters of negative displacement, 8 meters of negative displacement. So the displacement will be equal to the 18 meters up minus the 8 meters down, and we get a total of 10 meters.